focus on this, right? Just the 8. Is 8 equal to 2 cubed?
Yes.
Yes, it is.
So.
Okay.
So it's 9 over.
So stop guessing. Just pay attention and follow along. Okay. So if 8 is raised to the 2/3 power, then that's the same thing as 8 raised to the 2/3 power, correct?
This is tough. I mean, I get it. That's just like 256.
Okay. Does that make sense?
No.
All right.
Wait,
So I haven't changed anything. I just rewrote it. I just wrote it a different way.
Equals
yeah, but what happens
2/3.
on 32?
I'm coming. Isn't 32 2 to the 5th power?
See, senor.
Yes, it is. It is. Okay.
Just take a look.
2 cubed is 8. 8 times 2 is 16. 16 times another 2 is 32. All right. So going the same way here, 32 to the 3/5 is the same thing as 32 to the 3/5. Does that make sense? Okay, now this is a step-by-step explanation. Yes?
She's just carrying it down.
2 cubed.
This is the exponent of your 8. And 3/5 is the exponent of your 32. Okay? Now, this is what it means. This was our original problem, right?
Right.
But the bases were not the same.
So now you
I made the bases the same. It's the same problem. It's still 8 to the 2/3 times 32 to the 3/5. But now I can actually combine these by following my laws of exponents.
Does it have bases that are closest?
They're going to be. Okay? Okay, so let's just think for a second. We did 8 and 32. Let's just stop here for a second. If I gave you 2 bases, one was 9 and the other one was 27, what would you break them down to?
They're exponents.
3's to something. 3 squared and 3 cubed. If I had 25 and 125, what'd you break them down to? 5 squared and 5 cubed. All right? Yes. Okay. All right. Now, let's do, what's our first law of exponents that we have to look at? Power raised to a power. So what do you do when there's a power to a power?
multiply.
You multiply the exponent. So when I multiply this,
2.
what does it give me?
2.
2.
How you got that?
3 is understood to be 3 over 1 times 2/3. Multiplying straight across, 6 over 3 equals 2. Or, canceling,
2 over 1.
you got 2. What do you get when you multiply here?
You get 5
Three.
over 1,
Three.
3 over 5.
3.
3. Yes, there you go.
Okay? So we made our bases the same because they have to be. Well, we didn't change the problem. We just changed what it looked like. We did our first law of exponents by raising these powers to powers by multiplying the exponents together.
So we have no.
Now we are multiplying the two, so what do we do with the exponents? You add them. So it's 2 to the 5th.
To the 5th.
Did you plug this in a calculator?
So wait, do you keep it like this?
We might change.
If you can figure out what 2 to the 5th is, you figure it out.
32.
It's 32.
Hold on. I gotta write all this down.
So the answer's 32.
Yeah,
yes.
yes.
See the 32.
Could you have worked like 2 times 2 is 4?
Miss Sally, how do you do the
4 times 8 is 32.
how do you do to a certain power?
You're going to have to show her.
Oh, I got it. No.
Yeah.
Fine.
Okay.
You don't have to pass.
All right, hush. Now try this. And the only thing I threw in that's different from this one and the other one is the negative exponent. But don't worry about that till the very end.
Oh my gosh.
Okay, let's go back. What did we do first in the last problem? The bases weren't the same, so we...
So, can we not just multiply it, like since 8 and 64, like goes the same, like 8 goes into 64.
It's too easy.
We can't just multiply 8 times -2/3 or whatever, times 8.
No, you have to take your steps. You have to do your steps. You have to make your bases the same. All right, I can break these down to 2's with some exponents.
Yes.
Or, isn't 64 8 squared? I could just break 64 down to 8 squared, because then I just have 2 8's. Okay?
So it'd be 8 squared and 1/6 on the outside.
Right? Okay?
No!
Oh,
I just typed in everything and I accidentally pressed clear.
If you break 64
Hey,
down
my
to 8 squared,
also
you just
is
keep
not
that
that.
base the same.
The other base stays the same. Okay? So we've got 8 to the negative 2/3 times 8 squared to the 1/6. What's the first thing I need to take hold of? You said it. Finish saying it. Power to power.
Why are you squaring 8? Oh, 8 squared is 64. I'm sorry.
Okay?
Why would you make 8 1?
What do you mean?
Because 1 times negative 2/3 still gives you negative 2/3. The first one? I didn't change it. It's still 8.
This way you have the
You don't
same
have
base.
to. I mean, if it needs to be changed, then you have to. But I can just say this is 8 squared, and then I have 2 8's. Okay? It gives me the same thing. Same base.
Yes, Tyson.
The first number
Whatever floats you.
is 8 to the negative 2/3. How do you raise a power to a power? You multiply exponents. What's 2 times 1/6?
1/3.
Okay? Now I've changed to, I am multiplying 2 bases. What do I do with the exponents?
Add.
Add them.
Oh, there's no exponent.
So it'd be 1 over
It's like 3, so it's 3.
No.
8, 1 over 3. Yeah. Oh no, 1 over negative.
Oh my goodness.
I got it right.
So what do you do?
What do you have to put it over?
Hey,
Or under 1. Okay? Now how did I get this? Let's look. What does a negative exponent do? It tells you this is not where it belongs. Invert. So I have 1 over 8 to the 1/3.
that's an answer.
Well, what's the 1/3 mean? Cubed root, right?
Yeah.
Isn't 1/3 the cubed root?
No.
And what is the cubed root of 8?
2.
2. So the answer was 1/2.
How are we supposed to know that we're supposed to put a 3 radical?
Oh,
Because you're supposed to know that 1/3 is a simple cubed root and 8 is a perfect
it
cube.
sounds like it does work on the calculator. Oh my man. I'm gonna show you my work on my calculator every time I do it. I'll put like C memory on my calculator.
All right.
Oh, sweet.
Shh. Don't worry about the problem. Just look at what's happening. You are dividing variables. What do you do with the exponents when you divide variables?
Subtract.
You subtract them.
Can you make 1/2 2/4?
So it's 3/4 minus exactly.
I'll start making problems.
You have to make it 2/4 because he's a step ahead of us.
OMG, awesome distemper. Oh, run. Run for your life.
3/4
Jesus
minus.
is coming back. Sorry.
When I say shh, it means shh, Jacob. It's 3/4 minus 1/2. Because that's the law of our exponents. Well, since our exponents are fractions, when we're subtracting, we have to have a common denominator, which was 4. And what's 3/4 minus 2/4?
So that's the answer? 1/4.
1/4. T to the 1/4. Now, Tyson, or whoever asked, how do we know that we have to put it in radical form and simplify it?